Welcome to the OPUS Projektor tool training. In this video, I want to show you how to set up a J1939 message that should be received by the OPUS device. Once again, let's quickly go through the necessary settings. First of all, of course, you need to have your baud rate for the CAN port that you want to use set to the correct value. And then you need to go to Terminal and Owner ECU configuration dialog and choose on which CAN port you want to run J1939. I'll choose CAN 1 in the example. Then we have the settings for the OPUS device here in the middle. The most important is the preferred source address. This should be in line with the rest of your J1939 setup. You can also set the address claim to dynamic, so the devices will automatically talk with each other and they will switch to another address if necessary. In the bottom, you set up the ECU. There is a so-called any ECU for broadcast messages already there, but you should always put in the ECU or ECUs that the OPUS device will talk about in the CAN network in your system. Here you basically have the same settings as for the OPUS device. You can set the address claim to static or dynamic, and most importantly, you set the source address of the ECU. This one you should already know. Okay, and that's it for the setup. Let's go and create a receive message. So we go to the J1939 configure mappings dialog by clicking the blue shortcut CAN button here. And first we have to give the PGN a name. I will just name it PGNR for receive 1. Important, you cannot change this setting later, so be sure that you have it in the correct setting, and then we click add and the message is created. Let's quickly go through these settings. We have the name and description. They are just for you. They are completely internal, so use anything that helps you understand anything later on. The mapping variable type is usually length, but still some ECUs might want to have them with a delimiter. Then you can choose this setting here, and you can choose the delimiter character right here. Here you set up from which ECU you want to receive the message. So we will go with our J1939 ECU. Little or big endian is a setting that pretty much comes from the ECU. If the ECU only understands big endian, you need to uncheck this, otherwise keep it checked. Mapping length is of course very important. Messages in J1939 can be longer than the usual 8 bytes from CAN open or CAN layer 2. So you can set any number. I think the maximum is 107.85. Let's see. Yep, that's the maximum. If you enter a number larger than 8 bytes, transport protocol will automatically be used. And if you enter a number up until 8 bytes, the length of the message has to be the same as the length of the actual message that comes from the ECU. Otherwise, this message will be discarded. So we will assume the ECU actually sends 8 bytes, and we will put in this number. Now for the PGN, you don't need to give the whole 29 bytes of the PGN. So no priority in the first bits and no source address in the end. Down here you have an example. For a broadcast PGN, you just enter the 4 letters, so FABC, FECA, depending on which PGN you want to set up. And for peer-to-peer, you set up, for example, EA00. So you use 00 as the, in this case, I think it's the source address. So it would be the address from the ECU, but this one will be filled out by the system automatically. So always just these 2 letters and then 00. The rest will be done automatically. we will use the FECA example. The priority can be set here. I don't know, I haven't seen much use of this, but if it is necessary for you, you can set any number here. Here we have request settings. So with this, for a receive message, you can set up that the Opus device sends out a request message for this message. So it says, "Dear ECU, please send me a message FECA now." And the way you set this up is either by using the J1939 standard request format, or if your ECU handles things differently, you uncheck this and then you can set up a completely customized PGN that the Opus will send to be able to receive this message. So you enter data bytes here just as your ECU needs to see them so that it will send out the FECA message. And also you can set this up to when it should be sent. So this message can be sent regularly every 100 milliseconds or so, or you can send it on a variable change. You can use any variable in your project as a trigger for this request message. So you have complete control when the Opus will send this request and so when to receive the message from the ECU, but we won't use that. Here we have the receive timeout in milliseconds. This one is interesting if you have set up your, no, not only, but mainly if you have set up your variables to be owned by the ECU. In this case, let's say we enter 500 milliseconds here. If the message does not come every 500 milliseconds, any graphical object in your project that uses the variable from this mapping will be grayed out. You've probably seen this some point if the CAN bus is not working or something. The graphical objects will be gray and numeric fields will have dashes instead of numbers in them. Also, independently of using the variable owners, you can use this event on receive timeout action, and then later on, if the problem is resolved, the on receive timeout resolved action. So you can put a JavaScript here to do something, pop up an error, an alarm, an error message or anything, or go to a specific page. And same, if everything is resolved, you can go back to the working page or the page that was used before or whatever. So this can be used to effectively handle a timeout of the sending of a message from the ECU to the Opus device. And now we come to the variables. This is very straightforward. In the Visual CAN Mapping tab, we have a graphical representation of the data bytes of the CAN message. As you can see in J1939, this is very long because, as we found out, 1785 bytes is the maximum theoretically possible. In this case, we have set the data length to 8 bytes. That's why only these bytes are usable, and the white ones here are disabled. So now we just have to put in variables here, and I have created an actual RPM variable that I can now put into the mapping. And that's basically it. You set up your message according to how the ECU sends it. So if it sends it this way, if there's something else here, you set it up like this. You have complete freedom. If you put in a wrong variable, like the target RPM, you just drag and drop it out of here and it will be deleted. And you can also modify a lot of things of the variable right here. First of all, let's say you know that the ECU or the RPM will never be longer than 8-bit. In this case, you could save the space and only map 8 bits of this variable. So what this means is that bits 9 to 16 of this variable will always stay 0, or they will not be refreshed from this CAN message. there's a little warning sign here showing that you did something there, but it's not an error, it's just to inform you. Okay, let's put this back to normal. Additionally, you can do all sorts of manipulation with the value. There's a formula down here which explains it very well. So you have your original can value right here, which first can be shifted by so and so many bits. Then it can be masked by a bit mask that you can set up right here. Then a first offset will be added. The result of all that will then be multiplied by the scale, and then a second offset is added. We have 2 offsets to be able to calculate from Fahrenheit to Celsius and vice versa. So it gives you a little bit more flexibility, and you can do some more complicated formulas if that would be necessary. And that's basically it. We click OK, and now we have set up the message. We can use the RPM now in our project, and when the ECU sends it, the value will be shown on the screen. See you in the next video.